So I'm listening to some CX communications. That's CQCX up here in the 7100 region of 40 meters. People are using older equipment and trying to get some of the old commercial and homebrew gear on the air in the old 40 meter novice band. So as we continue in our series on the Type 27 Hartley oscillator, we start out with the 6J5 last seen on 80 meters, and we're going to be putting the Type 27 triode on the board. So here it is, part 4 of the Hartley oscillator transmitter. So the next step is plumbing in the Type 27 triode in place of the 6J5 triode. You'll notice that I've used two different 6J5s in the video series, both the glass version, the GT, and the metal version. They're identical tubes, except the metal version, pin 1 is the shield connection on the metal tube. So there's no problem simply connecting pin 1 to ground all the time, because pin 1 isn't even present in the glass version, so there won't be any short circuit or any problem with it. Which one's more stable? Well, my guess would be the metal version, but you never know. The next step, we're going to replace the octal socket. We're removing the octal socket and we're going to replace it with the 5-pin that the Type 27 requires. I like to change one thing at a time and see what the results are, rather than changing several things and then wondering why it doesn't work anymore. So there actually wasn't much to changing the socket out. I did have to use a little spacer to bring it up a little bit because the pins went down a little further than the octal. But even the pins seem to line up nice. The plate's still in approximately the same place. The grid is connected underneath. It could have been either side. Everything lined up just like it did with the octal socket. I didn't have to do anything at all with the wiring but unsolder and solder to the new socket. Okay, I have the Type 27 in and warmed up. Let's press the key and see what we get. Noting a little bit of chirp on the signal compared to the 6J5. Now I have not touched the tap on the coil, and this is the first Type 27 that I'm trying. And let me look at the power output. Looks like it's the same power output. Might be a touch lower, but it's kind of hard to tell. Of course, at this angle, it's hard to tell anyway. It's a solid watt. Yeah, it's a watt out. Okay, this is Type 27 number 2. I've not touched anything. I've not touched the tuning or the tap. Let's see how this one... Now it's interesting because the filament in this particular brand seems to be a little bit brighter, but that might just be the way it's built. Let's try it. I think this is a little bit better tube. Still a little bit of chirp, but not as bad as that first tube. So you have to remember these Type 27s are very, very old, and they are a lower mu triode probably than most 6J5s. I think we can agree the 6J5 is a medium mu triode. The Type 27 is probably on the lower end of the mu scale, and that does make a difference with the feedback. So might just need to move the tap to get a little more feedback. It's pretty good though. So I move the tap 1 turn closer to the grid. Not bad. So we're going to call the Type 27 good. Now let's increase the voltage. I can't do that with this power supply unless I turned it into a voltage doubler, which I think would give us a little too much voltage. I'd have to use a voltage divider to bring it back down. But I do have other power supplies. I think I have one that's going to fit the bill, and I will get that other power supply over here and we'll see what this thing can do with a little more voltage. This power supply is set up for 225 volts. Let's see how our little Type 27 will handle that. Well, the frequency changed. Let's tune it in. Okay, that sounds pretty good actually. The Type 27 likes 225 volts. Let's see what happens to the voltage under load with this power supply. Nothing. That's because this is a regulated power supply. This power supply has a pass transistor and it keeps the voltage pretty steady. This is cheating, of course. Grandpa did not have a voltage regulator. Okay. Okay, let's look at our power output next. Looks like we're getting 2 watts out. So I'm not going to go any further. Next, I'm going to change out the coil to copper tubing, and I'm going to change the variable capacitor to something a little bit better.
So can I talk a little bit about the copper tubing? For 80 meters, you're going to need at least 15 feet of 1/4 inch outer diameter soft copper tubing. It's sometimes called refrigeration tubing. For 40 meters, 5 feet of tubing will probably do it. If you also want an output link made of tubing, add an extra 4 or 5 feet. I use number 10 wire for my output coupling link. Find a form like a chunk of PVC tubing or a rolling pin with approximately a 2-inch outer diameter. Flatten the end of the tubing, drill through it, and secure the end of the copper tubing to the form right on the end. Now wind carefully and tightly. You'll need some resistance on the tubing to get it to form. Do not kink it. 6 or 7 turns is fine for 40 meters, and 10 to 12 turns is probably fine for 80 meters.
Okay, so I managed to wind a pretty nice coil on a 2-inch form. And this looks like it's going to work good for 40 meters. It's not quite enough turns for 80, although with a high C type ratio you might be able to get this to work on 80, but I think it's too few turns to work on 80, but I think for 40 this would be fine. You take a plastic or a wooden dowel. Okay, that's what we're going to do next. We're going to put this in here and begin to work around the coil on a pass to try to get the spacing done. As I wind around with the plastic tool, you can see I'm starting to open it up. Okay. Experiment with the diameter you want to use here, but I'm trying to go for a, something like a 1-to-1 spacing so I can get the tap to work okay with the alligator clip. And I know approximately how much space I have, so if I double the size of the coil, I should be able to fit on my posts. There we go. Spaced. How's that look? So with just a few turns, I mean, the coil's not that big. Usually you can get away with 2 supports on the ends. But I did put an extra hole in the middle to get the middle support, even on so few turns, just to increase the rigidity of the coil and, of course, to improve the stability. In the spirit of changing one thing at a time, the new coil is mounted. I have not changed anything but the coil. The output link remains the same. For an 80-meter transmitter, typically you use 10 turns, maybe a few more. If this thing oscillates, and I simply put the center tap in the middle, then I would expect it to be lower than 40, but higher than 80, something in the middle. So let's see where it comes up with the capacitor in the same position, about 300 puff of capacitance, 6511. So it's just below 40 meters with 300 puff. That's not bad, actually. Let's see how the waveform looks. Good sine wave. It's not bad. A little bit of wobbliness there. A little bit of fuzz in the signal. Pretty pleasant, though. How much power is it putting out? Remember, I have not even touched the tap at all. That's just what it is, you know. See if I can get some light on that so you can see it. Not 2 watts, but it's over a watt. It's like a watt and a half. Okay. So for not touching anything, that's not bad. Probably I could tune 40 meters with this thing pretty easily. Let's try it on the counter. Let's see what I can do here. And of course I'm in a dummy load. There we are, 7048. I haven't really moved the capacitor too much. Okay. Yeah, 7048. So there's 40 meters. The output coupling link I really haven't touched either. It's got 5 turns. That may be too much actually for 40 meters. So here's where you can talk about possibly putting a trimmer in the ground side of the coil to be able to adjust the coupling a little further and to resonate that coil for 40 meters to get a little more power out. So these are some tricks. Can this be a 2-band transmitter? I think it could be. I'm going to try patting down the coil now and see if we can hit 80 meters. So next we want to find the bottom of the range with the variable capacitor. So all 365 picofarads in line. Let's see how low we can go with this thing. Okay, let's come down off 40 meters. Keep going down. Full mesh. 5738. And we're still not down to 80 meters. So we know we can put at least a fixed capacitor value of 365 puff on there. The goal is to have 80 meters probably somewhere in here with the padding capacitor in line. So you don't want it wide open. You want it someplace down this way. Okay, I now have a 470 picofarad capacitor across the tuning capacitor. Remember, we're only using one section, 365 puff variable. And I don't want to tie the second section in because that's just going to make the tuning even faster. So I'm only using half of this. Let's see where we are at half scale here, 50%. Looks like we're at 5 megahertz. Okay, so it did bring it down, certainly lower. Let's see how low we can go. Oh, 4 megahertz, just above 80 meters. We're close. So I would say a 680 puff would be just perfect. Let's get a 680 picofarad capacitor in parallel with this cap, and let's see where we are from there. 3673, not quite hitting the bottom of the 80 meter band with the 680. But my power output is way down. So perhaps this capacitor is not great for Q. Let me try a different capacitor in that spot. Let's see if we get any changes in the amplitude, because the the power output has gone down. Not happy. Not as much fire in the wire here in the tuned circuit. So now I have a 270 picofarad and a 470 picofarad across the 365 variable, and hopefully we can hit 80 meters. Okay, where are we? We're at 3.6. Yeah, we're in 80 meters now. Let's go all the way down. Okay, I can go down to 3.530. Close enough. So I had to put quite a bit of capacitance across there to hit 80 meters. But I have noticed that it has upset the output. The output's down around a couple hundred milliwatts, maybe half a watt. Probably the feedback is not right anymore. It's certainly not acting like it's very efficient anymore. So I think the low gain of the tube, along with not enough turns for 80 meters, the messed up LC ratio, and perhaps the lower Q of these fixed capacitors, is really hurting the performance on 80 meters. Not saying you couldn't make this work, but it was a lot easier when I simply had 10 or 11 or 12 turns here instead of just 7. So lesson learned, really these things are single band affairs. So if you're designing it for 40 meters, perhaps this is a nice looking coil. If you're designing it for 80 meters, you're going to need more like 10 to 12 turns. And of course this is pretty wide space. That's also hurting a little bit too for 80 meters. So there we go. I would say what we've learned from this exercise is you need to have an appropriate coil for each band. So here we have the 40 meter version of the Type 27 triode Hartley oscillator. As you can see, I've added a different front panel, and there's actually a vernier built into the front panel. And I have a sturdier capacitor, although the capacitor only goes up to about 200 picofarads, which is a little bit shy for 40 meters, I think. I had to add some extra capacitance to pad that to get to the bottom of the 40 meter band. And I don't like doing that because almost anything that you connect to this thing causes the stability to go down and also influences the efficiency and power output, of course. So I've got a couple of, these are probably 35 puff trimmer capacitors that are mica, and then a fixed 20 picofarad capacitor to pad this thing, so that when I'm just about fully meshed, when this is on 0, I'm at the bottom of the 40 meter band. And when I get up to around here, I'm at the end of the CW band. The vernier and the front panel helps a lot, the grounded front panel. So let's try to net this. So as you can see, it's much easier to net with that smaller variable capacitor and the vernier. I had to change the tap for the feedback in order to get the tone to be smooth and to cut down on any drift. But it can be done even here on 40 meters. Now the tube does not have as much gain on 40, and I'm probably not as well matched, but I'm getting about 1 watt out with 220 volts on the plate. Only 1 watt. Remember, with that we were able to get 2 watts out on 80 meters with 220 volts on the plate. So not as efficient up here on 40. I would like to try a little bit higher voltage, but I think it's certainly usable now on 40 meters. You could certainly get into a QRP, QSO with this at 1 watt out. I think I'm next going to try to temp fade and put a little more voltage on this thing and see what it will do. See if we can get a little more out of it. But I'm pretty happy with this. The normal maximum voltage on the Type 27 tube is 270 volts DC. I've got 284 volts here that should be able to handle that with no problem. And we might even be able to go a little higher. But let's try This happens to be a voltage that my power supply puts out, and we're not drawing much current, so it should be decent regulation. So remember, we're getting about 1 watt out with the 220 volts, so 280 is not that much more. Let's see if it can handle it. That's about 2 watts out. So that increased the power pretty significantly. So yeah, I guess you do want to run this thing at a little higher voltage. Yeah. So tonight I'm going to try to get a hold of VE7SL Steve. He's on the west coast in British Columbia on an island. Let's see if we can raise him. Let's see what we're doing here. That's Steve right there. Wow, first contact, Steve. Still daylight on the island in British Columbia. So there you go, first contact on the 27 Hartley, coast to coast, across the whole country, to a small island off British Columbia from New Hampshire.